Okay, so in this class we will discuss these questions. Okay, all of this will be on your tuition note if you have tuition note. Otherwise also you can just follow here because we're going to write it on the board. So first one is write the uses of concave mirrors, question 27. So commonly concave mirrors are used here. One common use is that it is used as concave mirrors. Okay, they are used as commonly used in, we can write along with me. Okay, commonly used in torches. Okay, torchlights, torches. Then and vehicle searchlights. Okay, searchlights by the police and all. Okay, to catch criminals or something like that. Searchlights and vehicle headlights. Vehicle headlights, that means the light of the car in front that gives visibility to the driver at night, right? Vehicle headlights for what? To get a parallel beam. Okay, a parallel beam of light. So let us just try to understand this little bit. You can write it down, and below that you can draw this diagram, which you need not do in exam. So this is this, and the searchlight of the car, or even torch or whatever. That's this one. The bulb is somewhere here, like the light bulb, let us say. Okay, this light bulb is this bulb. Okay, so what happens is that as we switch on the vehicle headlight or the searchlight or the torch, the light rays would diverge like this. Usually will go like this. These are the incident rays coming from the bulb of the torch. So after hitting there's a concave mirror inside the searchlight or torch or the vehicle headlight, and after hitting the concave mirror they become parallel. Okay, they become parallel. So these rays become parallel, and the ray which has gone out here perpendicular will reflect back and then go like this. So because the bulb is somewhere near the focus of the concave mirror, okay, what happens is that the rays coming out from the focus, we know that concave mirror is like this, right? And when we know this is a pole P, center of curvature in F, ray going parallel go focus, but a ray passing through focus we know become parallel. So it's like the bulb is at the focus. So the ray is look like coming from focus, hitting concave means they'll become parallel. No, two rays coming there, again parallel. So that is the idea behind this one. Parallel beam of light is produced by the help of the concave mirror inside the torch, searchlight or vehicle headlight, and a parallel beam of light is produced that can travel a long distance for the car, for the torchlight to give you visibility at night, or the searchlight by the police to catch criminals and all these things, right? So that is the first common use. Second use here, you can draw that for your own understanding, and the second use is here, or you can write B also, here A, like your tuition note, and this one, the second use B, let us say. They're used as shaving mirrors. So shaving or beautifying mirror, you can just write in short, used as shaving or beautifying mirror. Okay, now let's just try to explain this. So when you use this concave mirror here, this is a literal actual concave mirror for shaving. You need to bring your face close. Why? Let us see here. So in this case, we know you can draw rough with your pen, no need of compass to save your time. This is your ball. The ball is like this, means the center will be somewhere here, focus. So we know that in question number 24 here, you can just write your question number 24, tuition note. Okay, for refer, like that you write, because you'll understand. Case 6. you refer to case 6, you will understand. In this case, what happens is that question number 24, okay, just right here. Question number 24, tuition note. Refer that and you will clearly understand what we mean by this. Particularly the case 6. Case 6 on your tuition note or your previous classes. If you check the videos of the previous classes. So this object, your face, this is your face. So here, your face has to be between P and F. This is your face. So FACE, your face. Okay, let us draw it a little bit bigger so you can get a clear diagram. So here, this is your P. Center will be here because the ball is this way. So center of the ball is always inside the ball. Then halfway through is your F. So let us say this is your face. This represents your object, the face, that you're going to shave or put some makeup, like, right? Ladies makeup and all. So this is the face of the person. So we know that we'll learn this in case 6, question number 24, the array parallel, go to focus. And array going towards the C. After hitting mirror, we know it reflect back along the same path, right? So we can draw that a little bit better than that. Go like this. Then here, this one, okay, you can use the tube scale if you want to make it easier for you. So we'll go like this and it'll hit the mirror, reflect back and go this way. And these two reflected rays are never going to meet because they are diverging. So we produce them backward. As we produce them backward, they meet. And the image of your face is produced here. This is your image, which is much more bigger than your real face. So that happens only in case 6, virtually erect, behind mirror, erect. All the 5 previous cases were real inverted. So you can't shave. But if you're going to shave, you put it close to your face, concave mirror, real one, this one. Then you will be between P and F, your face. So you'll get a big face like I can see right now here, behind the mirror. Then because of my image of my face, which is much bigger than my real face, it becomes easy to shave or for a person to put makeup, right, lipstick and all those stuffs, right? So that's how they use it as a shaving or beautifying mirror. The second use. A question may come related to see, while shaving or using concave mirror for beautifying, where should you put the object or where should you put your face? Your answer should therefore be between P and F, because that's the only case when you will get the image of your face virtual and erect behind the mirror and magnified. All the other cases were really inverted, so you won't be able to shave, right? So that's the second use, B. Okay, let us go to the third use. The third use is C. Here, dentist mirror. It is used as dentist, by dentist, that means dentist mirror for, okay, producing or forming enlarged. Enlarged means magnified. Enlarged, or you can also use the word magnified image of the teeth. So when the concave mirror is used, you get the enlarged image of the virtual erect image of the teeth, much bigger than the real teeth. So it becomes easy for the dentist to check the teeth of the patient, right, for examination. Then another use that you can do here, 4 uses we have put here: large concave mirrors. Okay, large concave mirrors are used to concentrate sunlight, means collect the sunlight. Concentrate sunlight in solar. The word solar means solar heaters or solar furnaces. Solar furnaces means the solar heaters for heating water or cooking food. So solar furnaces. So this concave mirror will be able to collect so many rays of the sun, and thousands of sun rays, thousands and thousands, are collected to a small place in the box of the solar cooker. so many rays are concentrated, means brought together, then it produces enough heat to cook the food or boil the water, etc. Okay, so that's what are the main 4 uses of concave mirrors. Question 27. Let us go to the next question, 31. 30 is just you read yourself, that is like a GK question, so there is nothing to explain. So question number 31, let us go and see what is this. 31. So here 31, write the uses of convex mirror. Just now convex or concave, so uses of, let us do the other reverse mirror, convex mirror. Uses of convex mirror or mirrors. Common uses are used as rear view. Okay, rear view means rear means backside. Rear view mirror in vehicles, or some textbook will call it as automobiles. It's the same meaning, right? Used as vehicle mirror. And so the mirror that the driver uses to see behind him the traffic, so that he's able to see how many cars are coming behind him or from which angle. That is the mirror where it is used. Convex, it's always convex. Second use is, okay, B. This one is A and this B. They are fitted at rod bends. Fitted at rod bends. Okay, especially in hilly regions, rod bends to see images of vehicles. To see images of vehicles from the opposite end of the road. So this is a bend, let us say in hilly area, the road travels like this. So at bends like this, they put concave mirror, because the car coming here won't be able to see this side because of the hilly nature of the road. So this car, if you look at this mirror, can actually see the car that is approaching from the other end. This is so because concave mirror is curved outwards. Okay, this is because convex, sorry, not concave, convex mirrors bends outwards. You know this one by definition, that the mirror whose reflecting surface bends outward is the convex, bends inwards like a spoon, inside of spoon is concave, but convex bends outwards, giving a bigger, or we can call it as wider, field of view than a concave or a plane mirror, because it's bent outside, so you can capture the image of so many objects at different angles. If we use concave, then we won't be able to do that, right? So this is the second use of convex, use at rod bends. Okay, if you go towards in KOHIMA, if you go towards Josoma, you see a good number of these put at bends. Okay, Josoma village, or even at Raj Bhavan there is one. Okay, towards the lower side of Raj Bhavan. So you can actually experience it, okay, if you go there. So these are the two main uses of convex mirror. Now next is 32. So let us go to question 32 and write it down first. Question number 32. Here, question number 32. This is also, please write down question number 1. Actually, question number 1, textbook. On page 177, if you open your textbook there, later you can see that. Okay, so here on the tuition note is 32, but actual question is question 1 on textbook page 177. Let's write the question together. It says define principal focus of which is denoted by capital F, of convex mirror. We have done this before, combined with concave. But here the question is asking us to define separately. So let us draw quickly the convex mirror to understand it. And then we'll define after that. Draw. Convex means C should be this side, because you're going to draw with your compass like this. Non-reflecting should be on the right. This is the ball. That's why the center is there. Between that is midpoint is F. This is the pole. So here let us draw a ray passing onto the mirror parallel to principal axis. Incident ray. Another one here below. Let's draw it in advance. These two incident rays are parallel to the principal axis. The condition is like that. Now put your scale here and here. And then on the left side of the mirror, left side, you draw full line. On the right side, on the same straight line without moving your scale, draw broken lines. The ray will go parallel. Principal axis means it will bounce back outside like this because the curve of convex is outwards. Now look here. So do the same with the other one. On the left side, full line. On the right side, broken lines. And interestingly, this is the reflected ray. These two reflected rays here, 1 and 2, they look as if they are coming from the same point F. They are not coming from here. They look as if they are coming. Look at the arrow direction. As if they are originating from here. But actually this one is originating from here. This one is originating, this second ray is originating from this incident ray. But after bouncing, because of the direction of reflection, because of the arrow direction, they look as if, I said as if, not actually coming from here. So that point from where that reflected rays look as if they are coming from is called the principal focus. So let us define it here. Write together. Now you have understood, we can write it together and I think you'll understand yourself. Incident rays, it means at least 2 or more. Even here we have taken only 2. You can put another one, 3, 4, 5. All of them should be there for parallel to principal axis. Incident rays traveling close. Close means not so far from the principal axis. Close and parallel to the traveling close and parallel to the principal axis. We know what is principal axis. The straight line passing through the C and P. This one. Close and parallel to principal axis of a convex, because they are asking specifically for convex mirror. Okay. Appear, they do not actually come from there, but appear means as if. Appear to diverge. Diverge because look at the arrows here. They are going more and more away from each other. They diverge. Coming to the same point is converge. Concave, they converge, but convex, you can see here direction arrow. They're moving more and more away, so diverge. But they are appearing to diverge from a point. That means a single point, the same point, from a point, this point. And this point is on the principal axis, from a point on the principal axis. So this point is not outside the principal axis, it's on this line. That's why we're mentioning on the principal axis. When does this happen? After reflection. After reflection from the convex mirror. After reflection, full stop. Let's read again. Incident rays traveling close and parallel to the principal axis of a convex mirror appear to diverge from a point, means from the same point, and that point is on the principal axis. This happens, they appear to diverge from this point after reflection has taken place. This point, the point from where they are diverging, this point is called principal focus. Okay, principal focus, or you can simply call it as, in short, focus, and denoted usually by capital F. So that is the definition for define principal focus of a convex mirror along with the diagram. If you do it, it's good. So you can just write here if you want. Focus. So 27, 31, 32 done. Let's go to 33. Okay. So question number 33. Question note. Question note. Okay. Question number 33. This one is on the question note 33. But on the actual textbook question, this is question number 2. textbook. You'll find this on page textbook 177. So let us see what is the question. Radius of curvature of a spherical mirror. The radius of curvature, okay, of a spherical, you write along with me, spherical, even if you have it on your tuition note, just write it, mirror is 20 centimeter. What is its focal length? What is its focal length? So this is the question. Let's just do here. Here, as you read the question, R is equal to 20 centimeter. The radius of curvature. Okay. Now we cannot look plus or minus because they did not tell us whether it's concave or convex. They just said spherical. So in those cases, we cannot use sign convention. F is question mark. But we know the mirror formula. Since F is equal to half of R, we can get that clue, half into 20 centimeters. So 210 means focal length is 10 centimeter. So that is 33 also done. Now 2 more questions. Let's go to 34. Question 34 is the question number in your tuition note. This is an actual textbook question. Question number 3, textbook, page 177 again. Let's see what is the question there. And let us write it together as we do it. There, name the mirror that can give an erect and a large image of an object. Name the mirror that can give an erect and enlarged image of an object. So let us just write the answer first and we'll explain it, because you are now used to the explanation, so I think you can easily pick up. So here the answer is concave mirror is the only mirror that can give enlarged image of object. Okay, they can give erect and enlarge. You see here, why? Because you'll remember here, refer question, write down 24 tuition note, okay, case 6. If you go up to your previous classes, check the previous videos, you have written this one, question 24, case 6. There you will see in case 6 like this. So let's just draw it again. Just draw it quickly, about 6 centimeter maybe, P, halfway at 3, F. Then here you draw object. So this is your object. So object, let us say, or you can just put it here, or I'm writing in short object, OBJ. Okay, so draw a ray parallel principal axis. We don't need to draw this, we are explaining, so just draw it for your own understanding's sake. So in this question we'll see like this, then this ray will go to the focus. We know the rule, a ray parallel to principal axis always go to focus. This is the reflected ray. And then we put a scale at C and top of the object, draw a line up to the mirror, and on the right side we just draw broken lines. As long as you want, you can draw. Then this ray is coming from C directions, in the same line with C, so it will go. In such cases, the ray reflect back along the same path, and the reflected ray will travel this way on the left side. So these two rays are diverging, so they are never going to meet. So we need to produce the first reflected ray also on the same straight line backwards till it meet the first one. That will cross extra also. Where they cut is where you get the image. And this is the image. And we know this image is virtual. As you can see, not formed by real rays, so virtual, erect, and magnified. You can see it's much taller than the object. So which mirror can produce erect, and enlarge means magnified? Only concave. You know that question number 29, for convex there are only two cases, and convex mirror can only form virtual erect behind the mirror, but always diminished. Convex mirror can never form enlarged virtual image, they form diminished virtual image. Concave mirror is the only mirror that can form virtual, erect, magnified. Convex forms virtual, erect, yes, but diminished. So that is your answer, right? So let us, 34 is done. Last question before we end this class, 35. So let us go to question number 35. This is also a textbook question again, question number, I think 4, yes, question number 4, textbook, page 177. All these questions from 32 to 35, I think, or 31, are all textbook questions. 32, from 32 to 35, tuition not number, but they are all textbook questions. 1, 2, 3, 4 on page 177. Let's see what the question is here and try to understand. Because once you understand, it becomes so easy to manage it yourself. Why do we prefer? So let's just write actual question. Why do we prefer? This is an important question. Prefer a convex mirror. Why do we prefer a convex mirror as a rear view, means backside view mirror, rear view mirror in vehicles, and not concave, and not even plane mirrors? Why do we always use convex? We'll see here. No, understand this. Just write down. You don't need to write this in exam. Refer question number 29. Okay, tuition note. Or you can say check the previous videos to find in which question 29 was explained. You will understand very well. Now as you read this question, we see here, number 1, convex mirror forms always. First reason is this. Write it down and I think you'll remember. Convex mirror always, not sometimes, always forms virtual. What is the advantage? Virtual and erect image. Okay, virtual and erect image of the traffic behind, of the traffic behind, means the image of the vehicles behind. That's advantage or not? Because this is now a real convex mirror, the kind used by cars to view by the driver to see the back traffic. Now this mirror convex, we learned in question 29, forms only virtual and erect. It never forms real inverted image. If it is real inverted image, problem is, if it is real, then we need a screen, and while driving you cannot be putting a screen to get an image. That's virtually impossible, right? So and then second, inverted means it will give you a very difficult view of the traffic behind. But here virtual means, what is the advantage? We don't need a screen. The driver can see it behind the mirror directly while driving. So there is no need of screen. That's why virtual is an advantage. And erect is advantage because the car behind him is erect and the image also erect. So it gives a better judgment of the position of the car behind him, right? So virtual, no need of screen, so very advantageous. Erect, so a good judgment of the position of the vehicle behind you. That's why. So reason number 1. Reason number 1 is it forms only virtual erect and never real inverted. Number 2. Since this is very important point, since convex mirror is bent outwards. Okay, since convex mirror is bent outwards, it provides just write it down first. It provides a wider field of view, means to observe, field of view of the traffic of the. So that is the second reason why we use convex mirror as a vehicle mirror. Now, since convex mirror, we learned in our second or third class that it is a spherical mirror which bends outward like the outside of the spoon. So its field is bigger because it bends outwards, meaning it can capture the image of the car not just behind but even at an angle. So that car behind also 2, 3, 4, 5 cars, 2, 3 cars like that. But if you are using a concave mirror, then the bend inside means you can get only the, at best you can get, even if you're getting virtual erect, I guess you can get the image of only one car. So the view is limited. But when you use convex, because it's bent outwards, it can capture the image of the vehicle a little bit on your right, a bit on your behind, and the car behind it also. So because of the outward nature of bending, gives you a wider field of view. So that is better, right? If you can see positions of more vehicles behind you and the tree, etc., right? So that is the advantage. So these are the 2 reasons why we use a convex mirror for rear view. Okay, this concludes your class. We'll continue in the next class.